Okay, so here's the question modified. I kept everything the same, but what I added there to the question was calculate new line current after installing a 1.5 kVAR capacitor. So in this question, for this instance, we've been given the capacitor we're going to install, and we've been asked what will the new line current be after you install this size capacitor. So don't forget, the first part of the triangle, it did not change. The wattage, the power factor, the VA, and the VARs, those are all the same. But because we're not installing the same size capacitor, or we're not correcting to a specific power factor now, but rather we're using a specific size capacitor to solve what is our new line current, our second triangle will change other than the wattage, which again was based off the motor's parameters. That will not change. So what I've done is I took my original VARs and now I'm going to subtract the size of the capacitor we're placing in the circuit, which is 1500 VARs. Those are the corrected circuit VARs, or that second triangle that's smaller than the big one, the other one there. Those are the total VARs for that triangle. So that gave me 2,000, you can see step one in black, sorry, 2,976.89 VARs. I put that on the smaller triangle, so now I have the wattage and I have the VARs. I can solve my VA by using Pythagorean theorem. My VA, or my corrected VA, is going to be my wattage squared plus my VARs squared, square root it. And this time I get 5,302.5 VA. So I now have my second triangle built with the new capacitor placed, the 1500 VARs. Now I can calculate step 3, I can calculate my new line current. So again, it's going to be the same steps as before. The 5,302.5 VA divided by my voltage, which was 240. My new line current, you can see in the bottom right there, 22.1 amps. So a little bit higher. I placed a smaller capacitor. My line current's going to go up slightly. So I have 22.1 amps. Now, if we continue to decrease the size of our capacitor, we will increase our line current, possibly putting us into a position where we have to increase our wire size, our conduit size, expenses start to grow. Now, I went to step 4. The question didn't ask it, but for good practice, out of curiosity, well, what would our power factor have been had we installed a smaller size capacitor? So I'm just doing my wattage divided by my VA. My new power factor would have been 83% or 0.83. So this is a situation where you've been told what size capacitor you're placing in the circuit, and in this case I asked you for the new line current. I could have asked you what would a power factor be, as opposed to what size capacitor is required to improve our circuit power factor to, X, and it's usually 0.9. So a question done 2 different ways. You're going to be asked this question of this magnitude on your test, as in, here is the size of the capacitor. What is our line current now? So follow these steps. I'll post these videos today. If you have questions about specific worksheet questions, please send them my way. I prefer them again in the discussions board so everybody can see what the other students are asking. Adds more of a classroom setting for these online courses. The other thing I haven't mentioned, and I should have by now, but I have a lot of colors on the board. If you're having trouble focusing on what I need you to do, then please reach out to me. If you want me to do smaller videos, smaller chunks, please let me know. Also, I'm now going to move the video up. I'm redating. I'm going to push the quiz to May 14th and the test to May 28th. I'll update your calendar and I'll make an announcement. Okay? I'll just give us more time, more lead up for the quiz and the test. Thanks, and hope everybody's staying healthy and safe.